is Deepti Mittal. I'm working as a lead software developer with ThoughtWorks. I have total of 15 plus of experience working with healthcare and retail industry. Majorly working on building platforms using distributed systems. So I'm very excited about this whole distributed systems and building platform. I'm also a tech blogger. You can find my blogs on medium.com or deeptimittalblogs.com, where I have written a lot of blogs about Kafka and Redis. Manan and I will be sharing our knowledge and experience of working with Redis for last 1.5 years. Manan, do you want to introduce yourself?
Thanks, Deepti. Hello, everyone. Myself, Manan Gupta. I'm working as an application developer and I have around 9+ years of experience into this industry. So today we are here to share our learnings around the Redis cluster as Deepti explained. Hope it develops the curiosity within you folks to explore this tool further. Back to you, Deepti. You can start. Thanks.
Uh, I'm sure Redis is not a very new name here. I'm sure a lot of us know about Redis. It's a very popular distributed cache solution. If you do not know what Redis stands for, it's a remote dictionary server because the main strategy for Redis storing the data is in the key value system. There's a poll. If you guys can just quickly take that do you know about Redis or not, will help us to give more idea that how much deep we should go into this topic. So what we'll be covering mainly today is Redis use cases where Redis is getting used into the industry, different topologies supported by Redis, what actually keeps the Redis cluster so healthy. We have been running Redis into production for almost 1.5 years, and we never ever had any issue in production because of the Redis. So it is very healthy. It has been working as expected, and this is all what we're going to share. In case of failure happens, how the new leaders get elected, what happens when the node does not reaches to a right node, when the request does not reach to a right node, how data gets synced across master and slaves or with the disk. Moving on, some of the impressive facts about Redis is, Redis was developed in early 2009 by the guy, a developer called Salvatore. He developed Redis just to improve the performance of their internal product, and by June of 2009, Redis was a production ready, and he has been fixing lot of issues, adding features. He created a big community around Redis, which takes care of the stability or database corruption around the Redis. So there's a lot of big community support for the Redis.
Sorry,
Redis.
please stop you. I hope the screen is not sharing.
My screen is not shared.
Yeah.
Was it shared before?
No.
Was it shared before?
No. Even the voice. Actually, the voice is also dropping off, and sorry.
Sure. Let me go back and share it again.
Yeah. Now, yeah. It is not the screen, but the notes are coming.
Sorry for this, folks. Something is not working as expected, but Redis works as expected.
I was shared in between, but eventually it stopped.
Okay.
Sorry, folks, just a few minutes, please. Cool.
Okay. So I'll just move where I was. Yeah. So that was also a history of the Redis. Was that clear, or should I repeat the history as well?
I think I'll just quickly walk through again, maybe.
Okay. Redis was developed early 2009 to solve internal to solve the performance issue of an internal system by Salvatore. Uh, and by June 2009, Redis was very stable, was ready for production. This guy developed the whole community around Redis, and that community is very active in solving the issues. Again, adding new features to the Redis. If you did not know, it stores data in memory, uh, not to the disk for the active usage. Uh, where most of us are very excited about, using OOPS concepts to develop a big system. Redis is actually built using a C, a very procedural language. If you want to learn how to write a beautiful code in C, you should look at the Redis code. I have gone looked into that code multiple times to understand how they have implemented a lot of features. So very beautiful written code using a very basic language like C. Um, Redis improves performance, but it is still a single threaded. So if you want to know how you develop, how you take away the complexity of threads, but still build a very performant system, Redis gives us that learning as well. This spawn background processes, which me and Manan will talk in future slides. But what Redis does is that they process only one request at a time. Hence, they do not needed a multi-threading in their main processes. Uh, so this is a simple use case about any cache system. You can replace this Redis with the Hazel cached or man cached, anything, where the client sends a request to the service. And if you want to, process that request faster or improve the response time, the cache system get introduced here, where the data is read through cache and returned back to the client. If data is not found into the cache, it is retrieved from the database, the cache system is updated, and then the response is returned to the client. I'm not going a lot into the right side. I'm just giving an idea that, where the distributed cache system is basically getting used into the industry. There could be a multiple way to implement this whole uh, right side of the solution, where you will make your distributed cache system aligned with the whole architecture. But there are a lot of industry use cases, where Redis is getting used very actively. And some of them to name here is the very big names like LinkedIn, like Twitter, LinkedIn, Pinterest. They uses Redis a lot to show the recent posts. So they keep that data into the Redis, where when somebody logs in, the first thing they want to see is the recent post, and how they create that timeline very beautifully with, very few milliseconds of time. Dream 11, most of us know. If you're following cricket, I think you know Dream 11 because there's a lot of advertisement around it. So in Dream 11, that leaderboard, which gets updated pretty fast, uses Redis. It uses a set data type for the Redis, which keeps the data sorted every time whenever there's a scroll changes. Stack Overflow uses Redis to show the top voted questions at the top. If you have been to US, you must be familiar with the DoorDash. It's a very popular thing like Swiggy for us. They have built a lot of machine learning to come up with the preferences or the suggestions, and for that they store a lot of data into Redis for the faster access. Tesco is using Redis to optimize their supply demand pipeline across stores and warehouses. So these are some big names where Redis is getting used in a different use cases, but I'm sure in industry there are a lot more use cases which is getting solved by Redis. Now coming back to the topologies which Redis supports. So when Redis just came up, it was supporting the Sentinel way of setting up Redis, in which you will just have one master node and and three or more slave nodes. Recommended is 2 to 3, because more the slaves, more the infra cost as well. So all the requests are served by a single master node, and the data is getting replicated across slave for the data availability in case of a master failure. We'll go into the data sync or failure in detail in the upcoming slides. So this is one topology which was supported by Redis at the initial days. When Redis 3.AO came, this is Redis 6.0 version currently, which is available as a GA. But when Redis 3.0 came, it came up with the cluster topology, which has been a very big game changer. This is what we have used in our recent project, where you can have n number of masters, and every masters can have their own slaves. The data is sharded among the masters. If you want to increase the parallelism, you keep adding the more masters here. All of these masters can independently service the read and write operations. Give you examples. When we were only serving the load of 30% of our client, we had I think 3 to 4 Redis masters. But when we scaled to a very large number, we did not scale exponentially. We just added few more masters because the parallelization was good enough. Redis provides awesome performance to serve these requests, where the most of the time just goes in network IO, not by Redis and accessing the data. If you have to choose between Redis Sentinel or Redis cluster, what the decision factors first is the parallelization. How much parallelization is needed for your applications is one deciding factor. The second deciding factor, which is a very important one, could be the hardware cost. Uh, because if you see Redis Sentinel, you just need a very less hardware. But if you are setting up cluster, 3 master is what is the minimum which you need, and then you would need slave for all 3 of those masters. Your data is not lost, your cluster is healthy even if one node goes down. So there's a lot of hardware cost associated with it. The third thing is data sharding, and definitely how big your data is gonna grow. If you have some of that idea, you will set up the cluster accordingly. So these are the 3 main criteria deciding between Sentinel or cluster. Uh, with that, we come back. What is that? What is the secret thing which is keeping the Redis cluster healthy? And I give it to Manan.
Thank you, Deepti. So folks, now we'll explore a bit about that how Redis as a cluster is able to give the performance and how it's able to maintain all the metadata. So basically in Redis cluster, nodes are only responsible for holding the data and even taking the state of the cluster, which includes mapping the keys to the right nodes. So cluster nodes are also able to auto-discover other nodes as well as detect non-working nodes and even promote replica nodes to the master when needed, and in order to continue to operate even when the failure occurs. So basically these operations are necessary in that case. To perform these tasks, all the cluster nodes are connected using a TCP bus, which is called the Redis cluster bus. As we can see, the grayed outlines, these is nothing but a cluster bus using gossip protocol. And as we can see through the lines that every node is connected to every other node in the cluster using this cluster bus. These nodes that we're saying, they use basically a gossip protocol to propagate information about the cluster in order to discover new nodes, to send ping packets, to make sure all the nodes are working properly, and even to send cluster messages needed to signal specific conditions like failure or something else. The cluster bus is also used in order to propagate, publish, and subscribe messages across the cluster, and to orchestrate manual failovers when requested by the users. So this is basically what gossip protocol is used for in the Redis cluster. Now, as we can see, we are in the diagram, we see 2 port numbers like 6379 and 13679. So what these are, each node in the Redis cluster has to open 2 port numbers. One for client communication, which in the diagram we can see is the 6379, And the another is for intercommunication between the nodes. For that, basically, it opens a different port number that could be 16379 in this way. So 16 port number is for accessing the Redis server by the clients, and 163 port number is used for communication between the nodes, which is nothing but cluster bus. Cluster bus uses a binary protocol, which is called the mission protocol, and it is used for efficient data exchange between the nodes. So as we explored a bit about Redis cluster, we'll go through the messages basically it exchanges onto the next slide. The gossip messages that we call. The first one is the meet. The meet is used, as we can see, to add a new node to the cluster. So through there is a command called cluster meet IP, which is used. Through that command, the node of the existing cluster will send an invitation to the new node, which aspires to join to the existing cluster. And then the new node will start communicating with other nodes. Moving to the ping, this is to exchange cluster metadata. The node sends a ping message to all the other nodes into the cluster for according to a configured time interval. Basically, a node timeout is one of the configuration that can be configured, that it should ping and wait for that particular response from the corresponding nodes. What this ping message contains, its own status, cluster metadata, and the metadata of some other nodes. So all this information is exchanged within the ping message. Next is PONG. It's to broadcast and to reply to ping and meet messages. So to explain a bit more, then this node is used, the nodes are used to respond to ping and meet messages. The structure of PONG message is similar to that of ping. It also contains its own status and other information. Whereas it's not restricted to just to reply to the ping messages, it can also be used to broadcast the information, whereas updating the cluster metadata as well. So an additional use case for the PONG message. The last is the fail. It's to broadcast the fail status of the nodes. So let's say a particular node has sent a ping message and it didn't get a PONG reply for a certain time interval, then basically we call that as a fail node. It's marked as a fail node, and the same has to be communicated across the cluster. So after a node fails to ping, it will broadcast the hang up message of the node to all the nodes of the cluster. So through these messages, each instance in the cluster can obtain the status information of all other instances. In this way, even if events such as like a new node joining, node failure, or even a slot change, the cluster state can be synchronized on each instance through the transmission of ping and PONG messages and other status as well through meet and fail messages. So after these messages are exchanged, where my cluster states lie. So after this, each node in Redis cluster maintains the current status of the entire cluster. What all it includes: the current cluster status, the slot information of each node, like which node in the cluster holding which key slots, which keys and which hash slots, and the master slave status of each node. What's the master slave status? And the last is the survival status or the suspected fail status of each node in the cluster. So these are the kind of 4 information that each node in the cluster stores after having talked through these messages. Moving on to handling master failover. So basically, Redis cluster nodes continuously exchange the ping and PONG packets. Those two kind of packets almost have the same structure and both carry configuration information, as we have seen in the previous slide. So the first diagram, what it says is the operating is the correct picture of a particular Redis cluster, whereby we have 3 masters and each master has 2 slaves. And using ping PONG messages, they have attained to a state where it's in working state and all the masters and slave are able to communicate with each other properly. So usually nodes send ping packets that will trigger the receivers to reply with PONG packets. However, this is not necessarily true. It is possible for nodes to just send PONG packets to send information to other nodes, as we said that it's able to just broadcast. So PONG message can be already also used for broadcasting the information. So let's say this is my state, and we come to the second point that my master has broken. My master has failed communicating with the rest of the nodes, and as we can see the cross marks, the slaves are not connected to the master, and even the rest of the masters which are in working condition are the connection is broken. So in this case, replica election happens. Election basically that which slave should be promoted to master. The one of the slave which is connected to the failed master should be promoted to master. And so basically we have two slaves in this case. Both the slaves will start sending failover requests to the another masters, right? And Redis, in order, it needs to and in order for a replica to promote itself to master, it needs to start win the election. Basically, two slaves have generated the failover request. Now it needs to get the consensus. Whoever will get the consensus will be promoted as a master. So Redis cluster uses a concept similar to the raft algorithm term. In Redis cluster, the term is called nothing but an epoch, and it is used in order to give incremental versioning to events, basically to messages. When multiple nodes provide conflicting information, it becomes possible for another node to understand which state is the most up to date using this epoch. In order to be elected, the first step for a replica is to increment its current epoch counter and request more votes, the failover requests from the master instances. Votes are requested by the replica by the failover auth request to every other master node of the cluster. Then it waits for a maximum time of 2 times, let's say whatever my configured node time timeout interval is, for replies to arrive. But at least for 2 seconds it will wait. Once a master has voted for a given replica, replying positively with a failover vote, as we can see in the third one, it can no longer vote for another replica of the same master for a period of configured time interval into 2. So for that time, that master won't be able to vote to another slave. So in this period, it will not be able to reply to other authorization requests coming from a different slave of the same master. So it is why what it helps, it is useful for preventing multiple replicas from getting elected. Basically, if this mechanism won't be there, then we could have a condition that both the slaves have got the equal votes and there would have been no consensus. So it would have been difficult to identify that which slave should be promoted to master. So basically this mechanism helps us to deal with that situation. So moving on to next one. In this case, if we see that the failed node, which one was the previous master, is now acting as a failed, and the slave has been promoted to master and started exchanging ping pong packets with the rest of the master. And the last diagram, what we are seeing is my current working state of the cluster. Now I have the failed node rejoined the cluster using neat message, as we explored in one of the previous slides. And now my new master also has 2 slaves, and it is connected to rest of the masters as well. So this is regarding master failover. Now we'll explore jump relocation. Basically, jump relocation, nothing but request redirection. So as we can see in the diagram that there are 16384 slots, and it's equally divided into the 3 master nodes. So Redis cluster divides all data into 16384 slots, and each node is responsible for some part of the slots. Like first node is handling 0 to 5400, second node 54012 to 10,800. So likewise, all 16,384 slots are equally distributed. And the algorithm used for that, as we can see in that hash slot CRC16 of key modulus 16384. This is how, when a new key gets inserted, to which particular node, to which slot it should land upon, is calculated using this formula. So this slot information, basically which node is carrying which slots, is stored in each node. When the client of the Redis cluster connects to the cluster, it will also store a copy of the slot configuration in its local cache. So what advantage do we get in this way? Basically, when client wants to find a key, let's say in this we made a first call of get key, that is get key 6408. It go, for example, as per its local copy, it knew that node 1 has that information, so it sent request to that, and we got a response from node sharing the what is the which node actually carries this information. So using that information, client updates its local cache, and then it's call to the corresponding node which holds the exact key, that is 6408. So just to summarize, I would say when the client sends an instruction to a wrong node, the node will find that the slot where the key of the instruction is located is not managed by itself. And at this time, this node will send a special jump instruction to the client, which will carry the node address of the target operation and tells the client to connect to this node to obtain this specific data. After receiving this instruction, the client will not only jump to the correct node for the operation, but also synchronously update and correct the local slot mapping table cache. All subsequent keys will use the new slot mapping table. So this is how basically the slot information is updated with the client, and it knows basically for the subsequent keys which node it should go to. This was about replication. Redirection. Moving on to replication. Data replication now will explore basically how the data is exchanged between the master and Redis slaves, master and slaves, and all other slaves, how the data is basically transferred across the nodes. So by default, Redis uses asynchronous replication, which being a low latency and a high performance, it is the natural replication mode for vast majority of Redis use cases. However, Redis replicas asynchronously acknowledge the amount of data they received periodically with the master. So as we can see in this first, in the diagram asynchronous, the first call, the client makes a write call to a Redis master. Immediately it receives a write call. It will acknowledge it back to the client. So client can start processing its own processing. For the client, the data has been persisted in the database. Whereas in the background, when this acknowledgement is given back to the client, Redis master takes care of replicating this data to all its slaves. As we can see, the point 3, sending the request, sending the data to the slave, and slave responding back with the correct updated status. And how it does, as we can see, replication ID and offset. Just to explain a bit about replication ID offset, using offset, basically master identifies that from which particular instant or moment it needs to send the data to to the corresponding slave. For example, my master had processed 10 offset till number 10, and it knows that its corresponding slave has processed only messages till 4th offset. Now, using that information, it will send the rest of the 6 messages to the slave, so that the information is updated in all the master slave nodes. This was basically asynchronous, and Redis also supports synchronous replication through the wait command. As we can see now, in the synchronous mode, client has made a write request to the master using a wait command. Now, wait command is able to ensure that there are specific number of acknowledged copies in the other Redis instances. Means its connected slaves have got the updated information from its corresponding master. When that is done, then only it will reply back to client with the acknowledgement that okay, it has received the data. So using this mechanism, basically our data availability is like guaranteed, but not guaranteed, I would say. It increases to a great extent, that even if we have a failover mechanism, my data is available in at least some of the nodes, but it cannot be guaranteed that the data would still be available. That is one of the still one of the drawback with this. But yeah, data failover problem is reduced to a great extent with this. This was regarding just the replication. I'll hand over back to Deepti to continue for the other ones. Deepti, you're on mute.
I'm sorry. Manan, can you confirm my voice is fine?
Yeah, I think it's fine now.
Okay, thank you. So it was all about how the data is replicated between master and slaves, right? But as Googlers say that every hardware is bound to fail sometime in their lifetime. How can Redis node be, saved from it? And as we talked about, right, initially that Redis stores all the data in memory. And if that machine goes down or the node goes down or it restarts for any reason, any data into the memory will be wiped off. Hence, Redis syncs the data to the disk store, and it does that in 2 ways. One is a snapshotting and one is a AOF, append only file. with snapshotting. What is snapshotting? Snapshotting is about whatever is the data in memory, it picks that up and dumps that into the disk. In append only file, it only keeps copying the delta after the last sync. In the snapshotting, there are three options. One is that client can initiate a background process. So if client issues a command to Redis called bg save, that means initiate a background process to sync my data from the memory to the disk stored. Another way the client can say that initiate the sync process as a main process. In that case, the client will issue a save command to a Redis node, which means that stop processing every read, write, or any other request which you are doing now. Stop processing that, and you should immediately copy my data from in memory to the disk store. Third thing is the condition based, which is a preferred way in snapshotting, where you can configure through Redis configuration that after how much request the data should be synced, or after how much seconds the data should be synced. The default value for condition based is after 10,000 requests or after 60 seconds, whichever is earlier, the data from memory is synced to the disk store. But snapshotting is not a default way by Redis for this sync. The default way is append only file, where it copies the delta, where it syncs the delta from the memory to the disk. It also has a three configuration. One is every write, which could be slow, but if you have a system which is very data critical, you just can't afford to miss any single write, maybe this would be the option for you. Another is every second, depends on the risk appetite your system has or your architecture has. This could be the another option. The third option is OS controlled. OS control is something, it leaves to the operating system to decide when the sync between memory and disk should happen, something which is not recommended because your system might behave differently in a different operating system. If append only file, as I said, this is the default strategy for Redis to sync data. And in this strategy, every second is the default option given by Redis. When you install Redis on your system, this would be your configuration, which is coming by Redis given by Redis for default. Moving on, so we talked about a lot of good things about Redis. Now I'm gonna share few things which we struggle little bit, or we'll say the limitation about Redis. Very first thing is no SQL support available like any other RDBMS or NoSQL DB, MongoDB, CouchDB, where you want to query the database and you can just select star. Not available in Redis. But Redis has a lot of API supports, and to overcome these limitations, we actually exposed the REST API endpoints. We built a kind of debuggability into our system by REST API endpoints, which internally used to call Redis APIs to query the data. But something which is not available, and if you have a data which requires this query thing, you might have to build something at your own. Security level access control or object level access control not very great in Redis like in any system. Or I know I work with MySQL and SQL Server a lot, where you can put a access control at a table level or entity level as well. But in Redis, once somebody has access of that node, they have access to that cluster, they can access the entire data. You can't control it object wise. Third thing, as we called out at very start side, is single threaded. So if you have a very high computing machine, Redis is not going to use a lot of core of it. It's happy with very few cores using. So yeah, that is something which you should consider when you are deciding the configuration of a Redis nodes. Huge RAM requirement, definitely, because all the data is getting stored in memory itself. Disk store is just for a backup. as Manan explained, right, it's a master slave architecture, and as every machine is bound to fail. So it has its own side effect of master slave architecture, where a master or a node goes down. It might take a few milliseconds for the whole topology to again be in a sanity state, the whole cluster to be in a sanity state, before it again starts processing the client request. Something which we did not see an issue at all in our production, but as this architecture itself has this issue. With that, we are done. We're gonna give a quick demo on the Redis right now. So whatever we've learned is theory. Let's see the practical now. Redis Insight is a great tool provided by Redis, which actually gives us some UI way to work with Redis or play with Redis. I've set up the Redis cluster on my local, which has 3 masters, and as Manan was explaining, right, Redis divides the data among 16384 slots starting from 0, and it distributes these slots equally. So you can see that's how the slots are distributed into a Redis cluster. Um, Keys also get almost equally distributed. This is where you can see how many node is holding how many keys, or how much space is getting utilized in every key. Redis APIs are very, very simple. It's as simple as set demo underscore 2 is my key, and demo underscore 2 is my value. It is gonna create a key with this name and a value with this name. And where can I see that? I can go to the browser and see this demo underscore 2 here. So this is one data type, the key data type, the simplest data type which Redis has. Another data type which Redis has, which has solved a lot of, where I was talking about Twitter or LinkedIn, they use this data type a lot, called hash data type, which is, it creates a hash kind of a structure. So if I say demo underscore 2, which is my hash name, and inside a hash name there would be key and a value, right? Multiple keys and values. So I say key underscore 1 and value underscore 1. 1 minute, let me try this again. I've set underscore 2 key underscore 1 and value. So usual thing, right? In the live demos doesn't work. But I have created that hash again, so I can show that this is the hash map which I created, and that's how it looks like. That I can add more keys here and the values here. We can use this as well to add a key and a value, key underscore 2 and value underscore 2. So that's how, if inside a key, it will hold a multiple values, multiple fields and values. Another data type which Redis provides is a set, which get used a lot into the leaderboard, where I was talking, right, that in leader Dream 11 or something similar, where or Rummy Circle, where the leaderboard has to change very fast. They use the set data type because it has a type called sorted, where you can provide a sorted criteria, and it will keep your data sorted all that time, which just get displayed onto the leaderboard. These are 3 main data types which has the Redis also provided streaming solution, which is coming very similar to the Kafka stream. Another feature I want to talk about, where Manan was showing the jump relocation thing. So if you see, I've enabled this redirection, and my node selected here is 7004. So if I add another key, demo underscore 3 and value underscore 3, you see it is redirected to slot 8377, which is N 7001. that's how the jump relocation actually works, because my slot 8377 is actually with 7001, which is here. Yeah. Yeah. Which is with this master. Now coming back to show you the topology. So if you select on this cluster management, if you select a master replica nodes, you can actually see the whole topology. I'm running 3 master nodes, and because it's local, I'm just running, 3 replicas of it. Um, you can actually play around here a lot, where you can save this 7005 port, or RA1, or RA1 is a replica of MA master. But if I want, I can make it a replica of, let's say, MC. See, it became a replica of MC, and then you can play around a lot with this. I'll move this back. I'll make this. I'll make one replica of this. We can also, okay, I think I have to refresh. Sometimes this UI does not refresh. Yeah. Another thing, another experiment which you can do about is, let's say this master has failed, right? The scenario which Manan was talking about, if a master has failed, a replica should take over. So I can do this failover here, which internally brings this MA master down and makes this RA1 as a master. The scenario which Manan was showing. This was all about Redis. I think we are at the end of the presentation now. If there's any questions, we can take.
Yeah, please feel free to ask the questions in Q&A channel. We'll try to answer it. We all have some questions if you already so.
Sure. Manan, do you want to read the questions, because I'm on the screen, sharing screen now.
Community version has some rebalancing issue. Any thought of the solution? Yeah.
Go on.
Actually, yeah, thanks, Api. Ideally, the enterprise version handles this rebalancing. There are some steps that we need to perform, like adding 2 new nodes, resharding the data so that the new nodes has the data, and then removing some existing nodes. So basically, that makes sure that the data is again rebalanced and distributed equally among all the nodes. So that's how usually why that rebalancing happens, because when it encounters that some of the nodes are some of the keys hash slots are not evenly distributed across the nodes, then only this kind of issue happens. So let's say we can create a pipeline maybe that takes care of adding 2 nodes and resharding and bringing the data into a consistent state where every node have equal kind of keys or almost similar kind of hash slots assigned to that. So using that, maybe we can handle this issue.
And the pipeline here, Manan, means is that you can write an automation script which can be either executed through Jenkins or any other tools which you use for, CI/CD to run this script. So all your resharding happens automatically. It doesn't happen to be a manual effort every time.
Yeah, thanks. I hope it answers that. Next question is there any possibility of filtration for the data while querying in Redis?
Yeah, actually, I forgot to talk about it. Though Redis doesn't provide a SQL support, but they have you can write a script in Redis using the Lua language, Lua scripting language, and that script can be run through CLI. You can run it through command line CLI. You can run it through this, that where you can actually pass a filtering criteria, and it will return those keys. That's one way. Another way is in our project, what we did, we actually developed a REST API endpoint, which used to take a filtering criteria and run the corresponding Redis APIs in the background and return us the results. So there are 2 ways, but if you're looking for a SQL support, it does not have. Redis Insight may you can do this. So I can say, let's say I can say demo here, and it is gonna filter. It's gonna filter, but this has not been very successful in production because you will have a huge data. You will have data in millions, and that's where this filtering is not very helpful. But if you have a data in thousands, maybe this might be helpful.
Yes, that's all, Deepti. Yeah, that's all.
Thank you so much, folks. I hope it helped.